We are recording now.
Okay. All right. Welcome everyone. So let's start. Before we start anything, let's start with a little bit of exercise. So you can do it either standing or seated. I'm going to flip my camera around. I'm going to stand, and so that you can see better. But yeah, if you feel like you want to just sit, that's fine. And it's going to be very light. Where's that? Oh, here we go. All right, let's switch my camera around, and I'm going to turn around here. Okay. So I can't see myself, but if you guys can't see me for some reason, hopefully I'm in the direction. So if you're standing, you want to walk in place. If you're seated, just move your legs up and down like you are walking in place. Move your arms, shoulders back. Breathing in through your nose, out through your mouth. We'll get warmed up here. Very good. All right. 3, 2, 1. Rest your legs. You're going to roll your shoulders back. Remember, still breathing. Never hold your breath while exercising. Your muscles need the oxygen. Good. 2 more back. 1, 2, and roll your shoulders forward. Good. All right, 2 more forward. 1 and 2. All right, so if you're standing, you're going to have your legs a little bit wide. If you're sitting, you could just widen your legs while you're sitting. Your arms are going to be out to a T. You're going to come cross body, twisting down, reaching towards the opposite toe, back up to center, and then the opposite side, reaching down towards the opposite toe. So if you're seated, same thing, you're going to reach down towards your feet, going side to side, twist at your waist. Very good. Let's do 1 more. Down and back up. Very good. All right, so our legs are still a little bit wider than shoulder distance apart. We're going to do a slight bend in our knee and then bring 1 leg up at a time. All right, if you're seated, you can still do that if you're standing. If you're seated, you can raise 1 leg up at a time and then lower down. Okay, so if you're standing, that bend, you want to keep your back straight. Even if it's just a slight bend, that's fine. You don't have to go into a full squat. Good. All right, let's do 2 more. Leg lift, and last one. And leg lift, very good. All right, legs back together. Our arms, sorry, my ceiling here. Our arms are up towards the ceiling. You're going to bring your elbows down by your sides, squeezing your shoulder blades together. Come back up, breathe in, breathe out. Bring your arms down, elbows down. Good. Up, breathe out, down. Last one, arms up, breathe in. Elbows down, breathe out. Good. All right, so last one, standing up nice and tall. We're going to bring our ear down to our shoulder, back to center, and then the other side, ear down to shoulder. So moving our neck side to side, breathing throughout. Very good. One more, back, last one, and back. All right, now we're going to bring our next, our chin down to chest, and then back up, look up towards the ceiling. Again, chin to chest, looking back up toward the ceiling. Breathing throughout, and back up. Good. 2 more, chin down, back up. Last one, chin down. And back up towards the ceiling. Very good. All right. So I'm gonna come back, turn my camera back around. Nice job, everyone. All right, nice job. Okay. All right, so, what did I do? Sorry, everyone's seeing, okay. Okay, so let's share my screen now. We'll get started here. Just take a moment. All right, I'll start recording. Okay, everyone can see my slide now?
Yes.
Okay, thank you. All right, so welcome everyone. I'm so excited to be here and glad that everyone decided to come too. So tonight we're going to discuss the science of exercise. So what is going on in your body during exercise? So I'm so excited everyone was willing to do a little exercise, so get our blood moving and get ready for our little science lesson tonight. All right, so and my name is Kathy Turney. A little bit about myself. I'm an exercise physiologist. I'm also a certified cancer exercise specialist. I've been working with Gildas since 2015. I teach the boot camp class regularly on Thursdays. We'll talk about that a little bit later. And I'm also a wife and a mom to 3 children. So if you are part of boot camp, you probably have seen them running in the background. Sorry. Okay. So what is exercise physiology? The definition is it's the study of the body's responses to physical activity, as well as how the body adapts to physical activity over time. So what an exercise physiologist wants to look at is what is happening within your body due to exercise and how those responses to exercise can affect disease. And within this definition, you can see that physical activity was mentioned twice. So let's define physical activity because you might have a question of what that is. Physical activity is any voluntary bodily movement produced by skeletal muscles that requires energy expenditure. This includes all activities and all intensities. So it is any movement that you control, any movement that's not sedentary, not sitting, doesn't include sleeping. And my little plug, it is movement that you enjoy. Don't think that you have to go out and get a gym membership in order to incorporate physical activity into your life. You want to do what works best for you and feels best for you in your situation. And exercise is very individual. So you want to do what feels good. Okay, so physical activity has been linked to a reduction in cancer risk. And there are several mechanisms here that talk about or that could lower our risk for cancer. So because of physical activity. So first we have the lowering of sex hormone levels. Exercise will also prevent high blood levels of insulin. And I should also point out that some of these listed here are specific to specific cancers. So the first 2 that I just read off, those are specific to breast cancer and colon cancer. Also, reduction in inflammation. Physical activity will reduce your inflammation, which can reduce your cancer risk, can improve immune system function, alters the metabolism of bile products, and reduces the time for food travel through the digestive system. Now, those 2 are specific to colon cancer, and also helping to prevent obesity, which is linked to many cancers. So I'm not going to go through each of these points and explain to you what happens within your body for each of these, because that would be very long and maybe boring for some people. But I want to say that research on specifically what is happening within your body to reduce your cancer risk is still very unclear. It's kind of a newer newer research that they are doing. But recent research that I did find in my research is that highlights one of these points. So that's the one I'm going to talk about tonight. Just highlight that one. So that one is you're improving your immune system function. And I will talk about that study that I found a little bit later. But first, I want to give everyone a little lesson on what the immune system is. And what are some of the key players within the immune system. Okay, so first, what is the immune system? It is the body's defense against foreign invaders or pathogens, we'll call them, that cause infection, illness, and disease. So there are external barriers to pathogens, which are your skin, your nasal passages, your hair. It's like that initial, those initial barriers that will prevent disease. And there's also internal barriers to pathogens, which are more at the cellular level. That's what we're going to talk about right now. So I'm going to define some things within the immune system. It's going to be a lot of scientific words, but the main point is what's really important here. So first, we are going to talk about leukocytes, which are white blood cells. So these circulate the body in blood vessels in the lymphatic vessels that parallel the veins and arteries. They are in constant patrol, looking for pathogens, looking for viruses, bacteria, and they find a target, multiply, and send signals out to other cells to do the same. So it's that whole response that happens, which we will talk about a little bit later. Leukocytes are stored in lymphoid organs. So if you see here on the right, there's a diagram of some of our lymphoid organs. So on the left, our primary ones, the thymus and your red bone marrow, which all blood cells are made start out in the red bone marrow. We have our secondary lymphoid organs over here, the spleen, Peyer's patches, and the small intestines, as well as your lymph nodes in the neck, armpit, and the groin areas. So within leukocytes, there are two main types. There are phagocytes and lymphocytes. All right, so first let's start with the phagocytes. So phago means to eat, consume, or destroy. So that's what these cells do. If you see this little diagram here, I have the pathogen in a circle. So a pathogen comes into the body and these phagocytes will surround it, then absorb it, then break it down, and then eat it or destroy it. So, and then down here I have listed different types of phagocytes just to show you that there's many different players here within the immune system, and they all have different roles. So for instance, we have our neutrophils. They're the most common. They tend to attack bacteria. Monocytes are the largest type. They have several roles. Macrophages, they patrol for pathogens and remove dead, dying cells. And mast cells, they have many jobs, including to heal wounds and defend against pathogens. So our second type of white blood cell is our lymphocytes. So they are our memory cells within the immune system. They remember and they recognize previous pathogens if they come back to attack again, and they begin life in the bone marrow. So on the left, we have some of these cells will stay in the bone marrow and they develop into B cells. B cells will produce antibodies and they help alert the T cells. So we have on the right, some of the cells will travel to the thymus. If you remember from our diagram before, the thymus was in the chest area, and they will become T cells, and T cells are the ones that will go out and destroy compromised cells in the body, and they help to alert other leukocytes. All right. So here we have just showing you a diagram of the differentiation of blood stem cells. So they all begin in the bone marrow and then they kind of differentiate. So on the right here, you can see the white blood cells. And we have within that the phagocytes on the left and the lymphocytes on the right. All right, so now that we know our key players in the immune system at the cellular level, We're going to talk about how they work together and defend our body against pathogens. And this is what we call the immune response. Okay, so the immune response is how your body recognizes and defends itself against bacteria, viruses, and substances that appear foreign and harmful. So protects yourself against those pathogens. And the immune system will recognize antigens, which are usually proteins on the surface of a pathogen, and attack and destroy them, or they try to destroy them. So the antigens, they're specific to specific pathogens. So let's say a pathogen comes in with an antigen on there that is circle shape. The body will recognize that as foreign. We've never seen that before, and will start the immune response and do its best to destroy that pathogen. Okay, so there are two different types of immune responses, and that they are called the innate and adapted or acquired responses. I will refer to it as adaptive instead of acquired, but I just wanted to put that there just in case. So here is a little comparison of the two. So first we have our innate response. That's very fast. So that's within minutes or hours, you're going to see a response. It's very generalized and it does not require an antigen. So your body will see something as foreign and will go and attack. So it's the first line of defense against a pathogen. Where you have the adaptive immunity, which is slower, which can usually develop within hours to days. It's very specific. It requires a unique antigen that your body will eventually remember, and it leads to immunological memory. And this will also, I'm going to wait a second to talk about antibodies, but this is where antibodies come into place for the adaptive immunity. All right, so I have a couple diagrams here just to see it a little differently. So this is the cells of each of the immune responses. So on the left, we have our innate response, which you can see is mostly our phagocytes, which we talked about earlier. And the adaptive immunity is on the right, or slower response. And you can see the B cells and the T cells are the main players in the adaptive immunity. Another diagram here, and they flipped it. So we have the slow response first, but if you look on the right side, the innate response is it's against foreign bodies, injuries, and pathogens. Remember, it's not specific. So anything foreign that's coming into your body, your immune system is going to, your innate immune system is going to start the attack. And here it shows like some bacteria coming into your nasal passages. There's protection on the outside of the skin. Let's see, mucous membranes within your body, within different organs. And like it says, it's the first attack. And then on the right, our adaptive immunity, it's very specific. You have the B cells that are going to start to produce antibodies. So they will recognize an antigen, produce antibodies that will recognize that antigen if there is a future attack. And then your immune response will work a little bit faster. And then the T cells will help to communicate it to everyone else. And same thing here, and this is just showing again, in the middle, the innate immunity. So bacteria or some sort of pathogen is coming in through the nasal passages, first attack, and then to the right of that, there are our phagocytes at work here. And then once it gets to the tonsils will start to produce antibodies against that. So then if that pathogen were to enter your body a month later, it would recognize it. And okay. All right, so we talked about that. Now let's, now that we have a basic review of the immune response, let's move on and talk about exercise and immunity. All right. So studies have shown that exercise does increase your immunity. but it is not exactly known how it is done to certain illnesses, but there are several theories. So on the next slide, you'll see some theories that have been have come out. So first one is up on the top left, is it may help flush bacteria out of the lungs and airways. So when you exercise, you're increasing respiration, which would cause bacteria to leave your body quicker. Down below that, it will slow down the release of stress hormones. So a decrease in stress correlates to an increase in immunity. Let's see, on the top right, we have temperature rises. So during and right after you exercise, you will have a rise in body temperature, which may prevent bacteria from growing. So that temperature rise may help the body fight infection better. And also, it allows antibodies and leukocytes to circulate more rapidly. So, so they can detect illness earlier, and then they might have before. So, and that kind of goes with as you exercise, your blood is flowing faster. So within your blood are those immune cells that will help to find illness earlier and start their immune response. Okay, so on the other side of that, too much or strenuous physical activity can cause immunosuppression. So that means that your immune system function will decrease or can decrease from too much physical activity. And that level, it's really hard to say what that level is. It will be probably different for everyone. But as a general rule, I would say that if you are finishing any sort of physical activity and you are extremely fatigued, so you should feel energy after doing physical activity. If you are feeling very fatigued after physical activity and you're doing this for several days in a row, then that could cause some immunosuppression. Okay, so let's move on to why we're here. So as I mentioned in the beginning, physical activity reduces cancer risk as well as recurrence. So now I want to talk about why that might be happening through our immune systems, using our immune systems. So again, research has shown that exercise can reduce cancer risk and slow cancer progression, but the mechanisms behind this are unclear. Let's see, but I did find some current research from 2020. It was a study in Sweden, and they showed how exercise stalls cancer growth through the immune system, specifically through our T cells. So here on the next slide, you can see they found that exercise improves the T cells' ability to attack cancer cells. And this was done through something called lactate. So lactate is produced in muscles and excreted into the plasma of your blood during physical activity. And it is a substance that aids in energy production. So that lactate was released. If you see here all the way on the bottom, I have an increase in lactate at the bottom, which caused your T cell activity to increase, which if you have more T cells from what we learned before, you're going to increase or activate your immune system. And the activation of the immune system increases the body's ability to prevent and inhibit cancer growth. So at the bottom, we have a decrease in cancer growth here. So that's what they found there. Like I said, there's not a lot of research on it. So it's actually pretty exciting to see some sort of research talking about what exactly is happening within your body that could be reducing your cancer risk during exercise. Okay, so now that we know that exercise has that ability or can have that ability, well, what do we do? Where do we begin? So I found this handout, which I can also send to Jasmine. It's from the American College of Sports Medicine, and it shows the effects of exercise on health-related outcomes in those with cancer. So if you see on the top, what can exercise do? So it shows the research that was done on prevention and survival of common cancers and how much exercise should be recommended. But as a general rule, you want to avoid inactivity. So be as physically active as you possibly can, whatever feels good for you. And to improve your health, you want to aim for 150 minutes of aerobic exercise per week and strength training 2 times per week. Start small though, it might sound like a lot. So you always want to start small and go from there. And then this is also a pretty cool handout here. So it just shows all the different outcomes from, you could see here, cancer-related fatigue, quality of life, physical function, anxiety, depression, lymphedema. So it shows what they recommend for exercise to help with those outcomes. So on the top has strong evidence, there's moderate evidence on the moderate evidence on the bottom. So I will get that handout to you. You can look at it a little bit. And if you have any questions about it, you can just contact me or let's see. Okay. And then also, so there are 2 programs that I am involved with at Gildas currently. First, there's a boot camp class, and it says boot camp. I know that might sound intimidating, but it's mostly a strength training class. We do some aerobic, some cardio, we do balance, flexibility, but that is every Thursday evening from 5:30 to 6:30 p.m. I do modify for anyone that needs it. And if you ever need to take breaks, you just take breaks. I know an hour seems like a long time, but you have to build yourself up to it. And also there's a series called Cancer Transitions. It's a 4-week series. It meets Tuesdays at 12 p.m. And the next session starts next Tuesday, May 3rd, and goes to the 24th. And I lead the exercise portion of that. So Cancer Transitions is a program for when you are done with your cancer treatment, now what do I do? And each week a different topic is highlighted, and then I lead the exercise session in the beginning of that to get the blood flowing again and brain moving. All right, so that is it. I want to thank everyone, and I'm open to any questions anyone has. And if you don't, if a question pops up later on, here's my email address, and Jasmine can also give that out if anyone doesn't have a chance to write it down too. So thank you, everyone.
Thanks, Kathy. That was great.
All right, I'm gonna go back to video. Let me see. Jasmine, should I go back to video then? Is that okay, or do you want this all recorded? Hi, Jasmine. Oh.
Excuse me, Kathy. I don't know if you
Yes,
can hear me.
I can hear you. Yeah.
Good. I was wondering, you know, they talk a lot about these antigens in terms of finding out if you were exposed to like COVID. But I'm wondering, can the antigens indicate if you have cancer?